Who's been using like the Slack channels for the rooms and stuff like that? Follow discussion? Yeah, the shared notes that are linked in there as well. Who did not know about that there's a Slack channel for every single room? Yeah, so there's a Slack channel that you can join for this specific room, and it's for discussion during this talk, but that's been happening for every talk in every room throughout the conference. So something to be aware of. I do have links to the room and the shared Google Doc in here, and there's going to be a QR code on the next slide for that. Something to be aware of. Who has never attended Mac Admins before? Whoa, that's surprising. A lot of you. Awesome. Well, I'm James Stewart. I'm here to talk to you about AutoPKG for Windows software. Hopefully you're in the right place. I've come to many of the Mac Admins conferences and was a volunteer in the beginning and started speaking at them after that. I think this is the same room I gave one of my very first talks on intro to command line, or at least it was this same setup. I don't know if it's the exact same room, but might have been one. And that was 10 years ago, which is hard to fathom right now. Kind of breaks my brain. I'm also curious how that's going to be signed. So, well, I should also mention this is actually an update to a talk that was given in 2015 on AutoPKG for Windows software. And I'm going to talk a little bit about kind of like how it started and where it is now. So this is the QR code. It goes to the same location as this link here. I also put this link in the Slack channel already. I will not be monitoring the Slack channel throughout because that would be very distracting to me, but I hope you all have fun in there. But at this link, I have the links to the various things that we just talked about, and then also links to my recipes and projects and other things that we're going to be talking about throughout this session. We'll give everyone a minute to grab that link. There's also the link to join the Slack if you still haven't joined the Slack. Who here has not joined the Mac Admin Slack yet? Okay. Glad you're at least in there. So I work for BigFix, and I use BigFix with this project, but BigFix is not strictly required for this. You could use any management tool to use AutoPKG to work with Windows software and then put that software into that tool. I am using BigFix. I'm not really here to talk about BigFix. I will talk about BigFix very, very little throughout this talk, maybe a little bit at the end to show some of the results of this. But really the focus here is using AutoPKG for Windows software. If you are using a different tool, you may need to work on a processor to help put the packages into that tool, but you won't need to work on processors to work with the Windows software because I've already written them and you can use them. So if you're not using BigFix or Chocolatey, you might need to do a little bit more work, but if you're using one of those tools, you kind of have a step ahead. But hopefully this will give you some direction of where you can go and what you can do, and hopefully inspire one of you to contribute processors to AutoPKG to work with other tools. So here's a little bit of what we're going to be talking about, a bit of why AutoPKG and what some of the values are and some of that stuff. Go over a little bit of AutoPKG itself in case you're not familiar, which hopefully some of you are already. Kind of where this project started, where it's gone, some of the issues that were solved along the way to make this work better for Windows software. So please ask me questions at any time. Please feel free to interrupt and interject or anything like that. We'll try to have you be on the catch box so that it's in the recording if you, have a longer, more complicated question especially. But please feel free to raise your hand and ask questions. But I do have some questions for you. Who's at least heard of AutoPKG before in this room? Okay, basically all of you, that's great. Who's used AutoPKG before? Okay, most of you, awesome. Who attended the workshop AutoPKG in Depth with Elliot and Anthony? I think Elliot was there. That's awesome. I'm not sure, I'm only going to cover a little bit about AutoPKG, so hopefully it won't be too much repetition, but I was not at that session, so I don't know. Who attended the Bringing a Mac Admin Mindset to Managing Windows Endpoints by Thumbtack? So really, some of the impetus behind this is a lot of what they actually kind of talked about in that session of kind of being jealous of Mac admin tools as a Windows admin and being like, wait, you have this AutoPKG thing? This seems awesome. I want that for Windows. Why don't we have that? That sucks. Like, how can I bring this to my Windows endpoints? And that's a lot of what they talked about in that talk, and that sort of using that Mac admin mindset and kind of like community collaboration and other kind of open source automation and other projects and how we can bring those across. So I really like that talk, and I thought it was related. Who here does not manage or use Windows really at all in your environment? Okay, a few of you. That's surprising. I hope that your coworkers get a lot out of this when you tell them about it. Only one of you. So I'm glad that most of you, or at least are, hopefully going to be able to use this more directly. But I was genuinely curious, since this is a Mac Admins conference, if some of you do not manage Windows at all. It is kind of funny how, you might be a Mac admin, but yet you still get, Windows duties at times. It is interesting, I've never actually been a Mac admin, not really. I've always been a Windows admin, but I really enjoy Linux and Unix and stuff like that, and I end up, using Mac OS personally, and I become kind of the Mac expert at different times and field a lot of Mac questions, and I really enjoy using the Mac, but I'm not technically a Mac admin. But I, really thought AutoPKG was amazing. And I really get a lot out of this conference. I've been going to this conference a lot, even though I'm technically not a Mac admin. So why AutoPKG? What's the value of AutoPKG? Why would I think that it makes sense to use AutoPKG for Windows software when it was really meant for Mac OS software in the first place? Well, you might think that just adding new software to your deployment tool is a simple line item, not a big deal. But when you actually go to break it down, there's a lot of steps involved, and there's a lot of places where something could go wrong, or where you could accidentally do the wrong thing, type the wrong thing, update the wrong thing in the wrong place. There's just a lot of tiny little steps that you have to do. And here are some of them, and it may vary depending on the tool of how complicated some of these steps are, how much time they all take. I think for me, it may only take me 30 minutes to do this by hand or something like that, but that assumes that I did it perfectly and didn't mess it up. Because if I messed it up somewhere along the way, I mistyped something, or I didn't update a value in the right place, then I may not find out about that for a day or so until someone says hey, you forgot something, and then I have to go and fix that. And now all of a sudden that 30 minutes has become multiple hours of both my time and others to come to me and tell me, hey, I did something wrong, can you go fix it? So automating what you can where it makes sense can save you time, and it can save others time, and it can just raise the quality of everything that you're producing and just make life so much simpler. The other thing that when I kind of started this project, my boss was really the hard part about a lot of this is knowing when a vendor releases a new version of software. Because if we have like 200 and some software products that we want to package and put into our tool and distribute and send out updates for, how do we know when one of those 200 products has released a new version and know to then do the work? So even if the work only takes 30 minutes or an hour to do, how do we know when to do it? And that's a huge part of the problem. And I was like, well, actually, AutoPKG can solve this for you. And it's really great at that. So what is AutoPKG? It's originally for automating macOS software packaging on macOS. Originally, it could only really run on macOS, and it was really designed for macOS software. That was really what it was for. And one of the key parts of it is AutoPKG is designed to only download the software if it's changed from the vendor. So you can run a download recipe in AutoPKG, and if the software has not changed, it will not download it again. So it saves you time and it saves you bandwidth. And so what that means is you don't actually have to go and check if you should run it manually yourself. You can just run it and it will only download it if it needs to, and great. So it kind of solves that problem for you. And then there can be lots of different automated steps and other things you might go along with it after. And I think one of the great things about AutoPKG recipes is there's really no coding required. We'll kind of get into that a bit more, but the recipes are just kind of like a set of instructions for AutoPKG to do. And sometimes that does feel complicated like coding, but it's not the same as having to like write Python or update a Python script every single time something changes a little bit. That's one of the beauties of AutoPackage, is like a lot of that complexity is in the recipe, not in the Python side. So it's a lot easier for people that are maybe a little less familiar with or less comfortable coding. So this is kind of a visual representation of how a download recipe works and kind of how all this stuff fits together in AutoPKG. So you have processors inside of a recipe, and you tell AutoPKG to run a recipe through its identifier, and that recipe has this list of processors in it that kind of go step by step. And each one of those processors is generally going to have an argument, and that argument tells the processor what to do. And in most download recipes, it's going to tell a processor to reach out to a web page and look inside that web page for a file URL to determine what's the newest file to download from that web page. And then once it gets that result, it gets passed on to the next processor, and that processor will then go reach out to that file URL for just the HTTP headers and compare that to its previous copy that it's already cached. And if those headers have not changed since the last run, it will not download the file again. Where if those headers have changed, then it will download it again. But this is kind of just like a good representation of kind of how recipes and processors and identifiers and arguments kind of all hook together and how they all kind of work together. Any questions on that? I guess that for those of you that have been to the workshop, maybe this has already been covered. So for me, when I say recipes, I'm talking about them being written in YAML. I don't deal with p-lists at all. That's how it used to be, is basically all recipes were p-lists. Since we're talking AutoPKG for Windows software, now you can write recipes in YAML. You can do that for macOS recipes or Windows recipes or any kind of recipes. For me, all recipes are YAML always. I find YAML much easier to work with, and when you're giving this project over to your Windows admins to work on, they're not going to want to work with p-lists because they have no idea what that is, and it's a challenge. And again, recipes invoke processors, specify arguments, call other recipes. That's kind of a tricky part of recipes, is you can have parent recipes to another recipe, and there's kind of a chaining going on. I think one of the most challenging parts of a lot of recipes, and download recipes especially, is you often need regular expressions. And that's like the one part of the process that I think feels the most challenging to someone who is maybe less comfortable with programming and stuff like that. I often feel for myself, whenever I go to write a regular expression that's new for the first time, I'm like, wait, what does this do again? And how do I write this? And I often have to go to like various web resources that kind of feel like I'm reteaching myself regular expressions every time. And I pick it up faster every time, but I still feel like I'm starting from square one at first. And I'm like, oh yeah, no, I do know how to do this and kind of get there. But for someone who has never written regular expressions before, that's honestly one of the hardest things to get over when you first get going with AutoPKG. Hopefully all of you who have used AutoPKG before are, at least familiar with that and the concepts. The processors that recipes call, that's where all the programming lives in AutoPKG. AutoPKG itself is written in Python. All of the processors are going to be written in Python. And most of the work being done in the processors is also going to be Python, although in some cases you're calling out to a different process that is not written in Python to do some of the work. So this is a very simple example of a recipe. It uses a processor that I created called assert input contains string. And it's like the simplest processor there could be and the simplest test recipe there could be for this. And I actually use this processor to like validate the output of other processors. And all this really does is say like the string that I'm giving it must contain the other string that I'm checking for. And that's it. That's all it does. It's very simple. But this is what a YAML recipe looks like. This is kind of like the minimal set of things that you need and kind of the minimal example of what it takes to write a recipe. So this is the inputs and outputs section for that same processor that I was just being called in that recipe. And usually you don't need to worry about the Python code or digging into processors in order to use them, especially if you have examples to go off of. And you can usually use those examples to get your way through, using a new processor for the first time. But one of the things that's extremely helpful in a processor is looking at this first section where the class for that processor is defined, because you're going to have a set of input variables and output variables that are defined, and that's kind of how you're going to interact with the processor. And that's kind of define how the processor kind of works and what options you have to put in that recipe. So you're going to see the same input string and assert string that was in the recipe here. Under that arguments section, that's what's going to be here in these input variables section. And then the output variables is what's going to come out from that processor. And you should see something similar to this in every single processor that's out there, regardless of it's for Windows or Mac, and so on. And then again here, this is probably like some of the few Python code that I'm actually going to show, but this processor is so simple that this is like basically it. This is like all the code for it. I'm just grabbing the inputs, and I am setting an output and then setting whether or not that result was found. It's a very simple processor, and you might say, well, this is so simple, like why did you write this? Why did you bother? I use this to test basically every single one of my other processors. So I wanted this processor to be as simple as possible so that I don't need to test it, I need to use it to test others. So that's kind of the core here. And then this is an example output of running that processor. When you run AutoPKG with a certain amount of verbosity, this is like verbose level 2, it will show you what the inputs were. It will show you the helpful message that I provided. This is the input and it must contain this other value, the underscore. And then it'll show you the output and say, hey, it was found. Great. And by default, if the string that's being asserted was not found, then it would actually throw an error and it would halt things, which is necessary for testing. So this is another example processor for Audacity for Windows. And in this case, it's kind of the same as any other Mac download processor would be. I'm still using GitHub Release Info Provider, which is a very commonly used processor to figure out what to download with AutoPKG, and you'll see that in a lot of macOS specific recipes as well. And again, there's that asset regex, which is one of the most complicated parts if you're new to regex. And the one thing that's different here is it's using URL downloader Python instead of URL downloader. And we're going to get into why and what the difference is and why that matters later. But this is like kind of the simplest possible Windows download recipe. Who has used AutoPKG with YAML recipes before? Okay, so a minority, maybe 30%, something like that. Who would like prefer plist recipes over YAML? Wow, I'm surprised that you are unsure. Oh, yes, okay, well that's a different reason. That's valid. Concerning, but valid. Okay, so AutoPKG for Windows Software 1.0. This was started by my coworker at the time, Matt Hansen at Penn State University. Hopefully you know what Penn State University is because you're here right now. So the idea was to use AutoPKG running on macOS for Windows software, because at the time AutoPKG could only run on macOS. It could not run anywhere else. And so that was kind of the idea, is to make use of this. And it was because we were already using AutoPKG for macOS software at Penn State. And so it was like, hey, this thing's really awesome. This is a really cool project. It's helping us a lot. How can we make this work with us for Windows software? And this actually started all the way back in November 2014. So almost, but not quite 10 years ago, which is pretty amazing that it's been that long. And so part of the key was Matt had to figure out ways to create processors that would run on macOS but extract metadata for Windows software. And some of those options involved using Wine, which is not a great option, would not recommend, but it's kind of what we had at the time and what we could figure out at the time. But things have come a long way since then, and that's what I'm going to be talking about next. And we actually both co-presented this work at MacAdmins in 2015. So there's a recording of that. You can watch that. It's definitely outdated because we say AutoPKG can only run on macOS, and that's no longer true. So kind of updating that talk here now. So yeah, I actually did some digging. I did some spelunking into some Git commit history. And this is actually when Matt first created a download recipe for Windows software or for non-Mac OS software. And it was for a crash plan. And what's wild about this is like we didn't have any processors. We did not have any way to do anything with this. What Matt was really doing at the time, as far as I'm aware, I guess I would need to double check with him, is basically using AutoPKG to know when there was new software and only using it in that capacity and not using it in any other capacity. So when he would do the AutoPKG runs and then check the output for like the daily builds, he could see, oh, hey, there's a bunch of Windows software that downloaded with AutoPKG. It must be new. I should go and either tell someone to go package it up and make it available for Windows manually, or I will go and do that. So it's actually just using AutoPKG exclusively for downloading software that happens to be for things other than Mac OS. And as long as you are doing it on Mac OS, you could do that for any software, any binary, any file. It doesn't really matter whether it's Mac OS software or Windows software. That's something that was always technically possible, and something that we legitimately found valuable to do at the time. So then Matt actually asked me, is there ways we can get information about Windows software, but do it on Mac OS. And so what I had to do, I kind of like helped out with this one at least, is research Python modules that were cross-platform capable that could read things about Windows binaries. And this is one that I stumbled across, which is this metadata processor library that is written in Python, and I think it's like pure Python, and so then it runs on all operating systems. It's not exclusively tied to Windows, where some other Python modules that you'll come across that work with Windows stuff will only run on Windows, and that's way less helpful for this exercise. So I came across this one, and I found out it would work on non-Windows, and I started playing around with it, and I was writing it on like an Ubuntu machine and making sure that it worked, and then I would give it to Matt and say, hey, does this work on Mac OS? And he'd be like, sure enough, it does. And so this is just a Python script. This isn't an AutoPKG processor. I was just like, how can I write a Python script to do this that's as simple as possible? And like at the time, I really didn't know anything about AutoPKG or how to write an AutoPKG processor, but I did have some experience writing code and writing Python, and I was like, well, AutoPKG is in Python. If I can figure out how to do this in Python, then maybe I can hand that over to Matt, and he can figure out how to make a processor, because I have no idea how to do that. I've since made like 52 processors, so a lot's changed in that time. But that's kind of where we started. And so then Matt ended up adding these other processors. So this first one here is based upon that Python script that I provided him. It's an AutoPKG processor that can extract metadata from exe files, generally. I mean, it can work with other files as well, but that's what we were concerned with. And then this MSI version provider that actually uses Wine and another tool to extract information from MSI files. It's not great, but it works. I mean, having a dependency on Wine, not fun. I mean, who here does not know what Wine is? I'm just curious. Okay, all right. Just want to make sure I don't need to define that. But yeah, it just allows you to kind of run Windows software in a very strange, hacky way. But it's awesome when it works. And then this Win installer extractor, this was using 7-zip on Mac OS to extract exe files. And then we were inspecting the results of that extraction to look inside of like text files and other things that we could parse on Mac OS to find the metadata that we needed. And so this is kind of like these first few processors that really kind of enabled us to go down this path. And we'll get to much better processors later in this talk. So here's like example output of, this is actually an updated version of that processor. It's not the same one. The original one was written in Python 2 days, so I couldn't really show you a demo of the output of that without being very sad and dealing with Python 2, which thankfully I'm long past. But yeah, so this has basically the same functionality. This is an example of it running and the output that it creates. And you can tell that it's looking at a Windows portable executable, which is what Windows executables are often called, and giving you a bunch of information about it, including like a creation date and a MIME type and some other things. I think in some cases we would actually get version numbers of the software with this processor, but I didn't have a handy example that I could pull up quickly to do that. But this is like some of the things that we could get out of it, but I think in some cases we could get even more. I just don't remember what those were. But this is like some of the value that you could get out of it at the time. So then, also in 2015, I went to AutoPKG and I took a bunch of the imports that were macOS specific and I put them in try except blocks in Python so that they would not hard error on anything but macOS. So basically inside of AutoPKG, there's a bunch of like Objective-C related Python binding stuff that I don't fully understand because again, I'm not really a Mac admin. And if you tried to run AutoPKG on anything other than macOS, it would throw an error and say, like, I can't do anything with this. I don't know anything about Objective-C. I don't know anything about Foundation plist. That's not going to work for me. And so I basically made it so that that was not a hard error. And what did I accomplish with that? Well, you still really couldn't run recipes at the time, but you could run the AutoPKG command, you could run help, you could run search, you could run the version command, and get some actual helpful output, and it would run instead of just blowing up and not running at all. And so this was kind of like a first step along the way to make AutoPKG run on other operating systems. And then I did absolutely nothing further with this. I made it so you could literally run the command, but not necessarily try to get it to be able to run just basic recipes. I didn't really go much further than that. But yeah, then in the time between, things have gone much further since then without my help. So URL downloader, this is kind of like the key processor that's used that you're going to see in almost all macOS related download recipes. And the problem with this processor is that it is not cross-platform. Well, it is cross-platform in a sense, in that it will use curl and it will download the files on Windows or some Linuxes, but in addition to macOS. But what will happen is it stores the HTTP headers for that request using something called extended file attributes, or xattr, and that only works on macOS and some Linux file systems. And so what happens is if you run this on some Linux file systems or Windows, you run it, it'll download the software. You run it again, it'll download it again. You run it again, it'll download it again. And this is a huge problem if the binary that you're dealing with is like 100 megabytes or a gigabyte. You're going to be, every time you do an AutoPKG run of all of your recipes that you care about, every time you're doing like a daily build or a weekly build of all of your stuff, it's going to download everything every time. And that means it's going to be way slower. It's going to take so much more time, so much more bandwidth, so much more storage. It's just not a great solution. And so this was like the main stumbling block that when I came back to AutoPKG years later and said, okay, let me try to run AutoPKG on Windows or Linux for Windows software, what was my main stumbling block? What was the main thing getting in my way? And magically, this was the main thing getting in my way, and a lot of other things have been solved since then by other people, like making it so that you could have recipes written in YAML instead of plist, and a bunch of other stuff. I'm not sure exactly when those things happened. Maybe others do, but I was like, oh wow, things have come a long way, things are much better, but this is still a problem for me. This really isn't going to work for me. I don't want it to download things every single time I do a run. That's going to be a problem. So like I said, now it already runs everywhere, and URL downloader Python is basically the key to making this all work, and we're going to get into that a bit more. But this real kind of reworking and focus on this project of using AutoPKG for Windows software for me really started in full in January 2022, which is not that long ago, maybe basically like a year and a half ago. And as a part of this, I created about 50 other processors as well, just to help out with various things and make all kinds of stuff. And these are all open source. They're all in my recipe repo that's linked from that link in the beginning. And a lot of these are actually not specific to Windows software. Maybe I'd say less than 10 are specific to Windows software. A lot of the other processors I've created are just really helpful for any potential use case. And for this project, we kind of focused on developing recipes on Windows. Even though you could technically do it on Mac OS, we wanted all of the people that were contributing internally in our organization to all be running on Windows. If they were, really technical or really already knew what they were doing, they could do it on Mac OS, or they could even do it on, Linux if they wanted to. But we wanted, if you want help from us to set things up and get things going and, get support from us, we really want you to be doing it on Windows. And that way you could have a single VM for dev and test if you wanted, even though you should probably have two. And yeah, that is kind of what kind of kicked this off. Any questions so far? Okay. So URL downloader Python. This is the processor that I came up with to allow you to run AutoPKG recipes and have them save the HTTP header information, and I'm saving it in a JSON file, a metadata file, instead of using extended file attributes. And this allows it to work equally well on Mac OS, Windows, and Linux. And without this, you would have the problem of it re-downloading over and over again. I've even heard of some people trying to run AutoPKG and have their cache on a network file share or something like that, and extended file attributes wouldn't work on Mac OS in that case. So there's even some weird cases where you could run into where URL downloader doesn't work, but this does. So it's really nice. It works everywhere. Very handy. And it basically solved my main stumbling block to kind of get going. And so this is what that looks like. Is on Mac OS, you would have the binary downloaded, and those extended file attributes would be kind of hidden. You wouldn't really be able to see them unless you went to the command line and ran some command that I don't remember, and it would kind of show you the values that are stored in the extended file attributes. In this case, the metadata is not hidden, and it's in this JSON sidecar file that I just called .info.json. And the way it works is the processor, it knows where it's going to be storing the binary file, and then it just automatically appends .info.json, and it knows to put the metadata in there. And it just always creates that file, and it always knows to look for that file. Because if you've run it before, you already have a download cached, then it's going to be looking for that file and that metadata file to tell whether it should download it again based upon the contents of that metadata file. And this is what that looks like. So I'm saving file name, file size, the download URL that was used to download it, and then this HTTP headers. And the HTTP headers is really the key. That's what's going to be compared. And you could have content length or ETag or last modified. You could have any combination of those. It just depends on the web server that the file was downloaded from, and it will do its best to compare as many of them as it can. And the more the merrier, basically. But these are values that web servers are supposed to provide for binary files, and they're not supposed to change unless the file changes. And when the file does change, they are supposed to change. There are some exceptions out there where there's web servers that don't quite behave properly, and you may need to tell it, oh, even though all three are provided by this web server, you need to only check these two because this third one, the web server doesn't actually handle it properly and stuff like that. And that is something that you can specify in the processor arguments. But this is where it's going to save that data regardless. Another trick is for URL downloader Python is you can ask it to compute the hashes for you for the file that it's downloading. And this is important for us because we use those hashes as a part of our process to validate the files when the client goes to download them in the future. But you can also use these hashes for other things, like some tools care about them. If you're going to build a chocolatey package with this, generally you're going to have the SHA-256 in there to validate the file. Lots of other tools use these things. You can also have, there's like a virus total processor that you could use a hash that's calculated to send that off to there. There's lots of things that you can do with these. Now, there are ways to do this with other processors, but the trick with URL downloader Python is it will actually do the hashing while it's being downloaded. So this happens at basically instantaneous speed. Like if you run URL downloader Python without computing hashing and with computing hashing, most of the time you will not be able to tell a difference in speed because usually it's the actual network process of downloading the file that takes the time, not the computing of hashes, because CPUs have gotten so much faster than our internet connections. Even at like a gigabit speed with a really fast and large file, you're still not really going to notice a difference. And so that's a really awesome feature of this processor is you can compute all of these hashes. And it actually computes the SHA-1, the SHA-256, and the MD5, all three of them simultaneously while saving the file to disk. So it's basically reading chunks from the web server, updating all of the hashes and the disk as it goes, which is really cool. It also means that you can run this in a Docker container that has 256 megabytes of memory, and it never has to read the entire file from disk or from the web server into RAM and calculate the hashes that way. I'm not sure if that's a limitation of any of the other processors out there that calculates hashes, but it's not a limitation of this one at least, which is very cool. So I ran a thing to kind of look at what are all the processors that we're using in our download recipes. And so you'll see in the other processors, like most of ours are going to use GitHub Release Info Provider or URL Text Searcher to sort of figure out what to download. And then we're going to use URL Downloader Python to actually download it. And then these are a bunch of the different processors that I've created that we're going to talk about soon that sort of replace those processors that Matt Hansen originally created for various reasons. And you'll see there's a whole lot of this file exe get info PE processor, and I'll get into that in a minute of why that is the case. But yeah, so these are a bunch of different processors that we've created and how often we're using them in our various download recipes. So yeah, these are the main processors that we created for getting metadata from Windows files. There are some additional ones. This file exe get info PE, this uses a Python library called like PE info, I believe, and that library is cross-platform. It works Mac, Windows, and Linux. It doesn't care, it doesn't matter, and you can use it to extract the file version from an exe or DLL file. Anything that's what's called the Windows Portable Execution format, which is generally EXEs and DLLs. But there might be other file formats that also have that same thing going on. The other thing is this file exe verifies signature. What this allows us to do is determine when the file was quote unquote released. So there's a couple different ways we try to get what will approximate the actual source release date from the vendor for the software. And one of the methods that's the most reliable is actually the date that the binary was signed. Sometimes that is like the day before or like a couple days before the official release date according to their webpage on the vendor's website, because they'll say, here's our update, we released it, here you go, and you check the date on that, and it was signed a couple days before that, which can make sense if they're generating the binary and then doing some testing and then finally releasing it. But it's close enough for our efforts. But what's also cool is it will actually validate the signature of the exe file. And this is also cross-platform. This works on Mac, Windows, and Linux. It does not rely on any Windows-specific binaries or anything like that. So you can validate exe files and validate that their signature is valid. We have found that there are cases where files are signed in such a way that the Python library that we're using doesn't quite see the signature correctly for some reason, where Windows will see it if we then go inspect it there. And ideally we'd be able to figure out why that's happening and why some files that seem to be validly signed according to Windows are not showing up as validly signed according to this Python library. But that's a kind of a problem that we've just deferred. But for all the cases where it works, this is excellent. And then there's a couple others here. This file exe version extractor. This is slightly different way of working. It actually uses 7-zip to read the files, and it can get version numbers in different ways than some of the other ones. And sometimes it works better than the other one, though that first one is definitely the one we use the most. The file MSI get info OLE, what we actually use this for is Windows MSI files have metadata inside them for the time that they were created or last saved. And this is not the file like modification time or file creation time, because if you just downloaded the file for the first time right now, that's going to be like the actual file creation time or modified time, and that's not a helpful metric. But what we're actually doing is looking inside the actual MSI file format, and there's actually metadata inside there that has creation time or updated time for the actual OLE database that's inside the MSI file, which is something I didn't really understand, but figured out a way to read that value. And so that's a way that we can approximate the source release date for software based upon that file type. We have found that in some cases it doesn't quite work because whatever tools they are using never updates this value properly, but we do use this where it does work, and it's a method that is relatively reliable. I would say like, I don't know, maybe 80% of cases where there's MSI files. And then this file MSI get property, it can get any property from any MSI. So if you've worked with MSIs and you've looked at like the property table inside of an MSI, you're going to have the product name and product version, and those are going to match what is going to show up in the Windows registry uninstall key for display name and display version, which is often what we're using to like detect if the software is already installed or not. And you can get those values with this processor. And this processor actually uses a Windows-only Python library if it's running on Windows, and then if it's running on Mac OS or Linux, it uses MSI tools. And so that's called out as a dependency for the processor for those operating systems. So yeah, these are definitely the ones we use the most and are the most valuable. So again, this file exe get info PE, this is kind of like, I realized in hindsight, a bad example to use Apple Software Update. This is a Windows binary from Apple. It's, I guess, something that maybe shipped with like iTunes or something at one point, and iCloud and that kind of stuff. But this is like an old version of that binary, and you can, this is like from Windows. You can right-click on a binary, you can hit Properties, you can go to Details, and most of the time you're going to see this information filled out. You're going to have this property and value, file description type, file version, product name, product version, copyright, and so forth. And I was like, well, there's got to be a way to read this somehow and be able to get this in like Python and then not have to rely on Windows to get this information. And like I was like, Windows knows about this. How does Windows know about this, and how do I read this value? And that's what I eventually figured out through this pinfo Python module, that I could run it against this and get this output and get all the same information. What I actually first did was like just write some different Python scripts that worked with PE format stuff that was cross-platform, and I wrote like a whole bunch of different scripts just trying to figure out which one of these modules would give me what I needed. And then eventually I found one that was like, oh, this gives me exactly what I needed. This works for me. And then I went and bundled up that into an AutoPKG processor. And you can see here, this is basically the same information. And it's really the version information that we care about the most, that we then use when we send it to our tools. And so again, you can, for the verify signature one, if you right-click on that on a signed binary in Windows and you go to digital signatures, you're going to see that there's this timestamp there. I'm like, well, Windows knows there's a timestamp and it knows when that timestamp was from. there's got to be a way that I can get that in Python. And it turned out there was, and that's what this file exe verify signature does. And so you give it the path name of the binary that you want it to inspect, and it's going to pull out source release date by default into the format that we want it for our use. But you could have it pull out any of the data that it is able to read. And I have it pull out a bunch of like default data. And part of that is like, is the signature valid or not? What does that result look like? It also gives you this serial number, which I think is supposed to be like the serial number of the cert that's signing the file, but I haven't like investigated that very far to figure out exactly what that is and how consistent that is. But it is something where you can actually specify the serial number that you expect to be the signature, and it will then check to see if that's actually true or not. We're not using that very heavily currently, but that is something that we're interested in investigating to kind of make this process more secure and more similar to how it is on macOS, where you have actual like this validating the who signed the macOS package, being able to like do the same thing, where you don't necessarily care exactly when it was signed in terms of like, is it validly signed, but who is the signer of it? Like, was it, if this is an Apple product, was it signed by Apple? If it's a Google product, was it signed by Google? That is not a problem I have solved yet, but is something that I would love to be able to solve in a cross-platform way, and then be able to have that like additional security verification. And like here's an example with the file MSI get property. So this is using MSI info because I ran this on my Mac. Like that's where this run is coming from, but it's getting the Windows values. If you were doing this on Windows, it would just use a Python module to do this, and it would not have to call out to a separate binary. But in this case, we're calling out to MSI info, and we're getting the property values and saving them. And in our case, also grabbing the version and saving that in the version value and using that later. So the results of our project. We have about 600 recipes. They're about 90% Windows. I haven't really talked about this up to this point, but we actually have recipes for Linux software as well. There's really no reason you can't do this for Linux software also. In a lot of cases with the Linux stuff, we're just using 7-zip to expand the packages and look inside them and do processes with them as well. In the last about 1.5 years, which is about how long, sorry, you got a question?
Yeah, what distributions are you supporting with Linux?
So the question was like, what distributions are we supporting with Linux for the Linux software that we're doing? It's kind of any and all that we can. So some of the Linux recipes that we have actually involve Java software, and that software can run on any Linux or Windows or Mac OS. It can run on all of the above. So we actually have the same download recipe to download the payload or to process the payload. And then we actually use templates. And so we'll have a Mac OS template, an AIX template, a Solaris template, a Linux generic template, and a Windows template. And all of those the same binary will be used for all of them. But then the actual scripts to do the install process will be different for each operating system depending on what's going on there. And one of the fun things is Bash and Bash scripting is not the same on Mac OS as it is on AIX, as it is on Ubuntu. So that's a really fun experience where it's like, oh, they all support Bash, right? Well, kinda. It depends on what commands you're using and what flags you're using and all that kind of stuff. But anyway, so in the last 1.5 years, we have all of these recipes. We run them every single day, build them every single day. And that has created 10,000 unique pieces of content with unique software versions. So if we do a run and it results in the same thing because there's no new download, we don't import it, we don't process it, we don't do anything with that result. We're just like, yep, we got the same result, and then we just put it to the side. So this 10,000 items generated, those are all unique items generated. And with our tool, what we're actually doing is for a lot of these products, we are generating install content, which is only applicable to machines that don't have the software at all. We're generating update content, which is only applicable to machines if they have a previous version already installed. And then we're generating what we call install/update content, and that content is applicable to any machine that either does not have it installed or has an older version installed. And so you can pick and choose what you want to deploy. So if you want a piece of software to be everywhere no matter what, you use like the install update content and deploy that out, and everyone will get it. And if they have an old version, they'll get upgraded. If they don't have it, they get it. So that's kind of why we get 10,000 items so easily, is because every time a new version is released for those items, we're generating 3 pieces of content. So that's what's inflating our numbers a little bit here. We have around 300 recipes in like full production use. We're using them completely. Others are in some stage of development or validation and are in the works to go into production at some point. We have around 100 or so that are disabled due to software or vendor issues. Like we find out that you can't really silently install the software for some reason, or it like pops something up at the end of the installation, which causes problems. And we're like, well, this is just not worth doing. We're just gonna forget about that. And so we actually go in and disable the recipes, but we often don't delete them because we want that to serve as an example, so that if we decide to resurrect it or try to investigate, oh, maybe there's a silent install flag that we missed somewhere, we can go and add that back in later and try it again and bring that back. Right now, we're mostly focused on the easier things to do and haven't really tried to resurrect any of them that we've pushed to the side, but theoretically, that's the idea, is that we can do that. The other thing is we'll find that like maybe 1% of download recipes, 1 to 5%, may break in like a month, and we may have to go back and tweak them slightly to update them for like a vendor web page change. May need to go tweak a regex or something like that. That's just kind of the realities of AutoPKG, even if you're doing it for macOS software. Like the fact that we're doing it for Windows software is kind of irrelevant in that case. It's just something that happens and you got to go fix it. But thankfully, you've already done most of the work. Usually you just have to make a few tweaks and you're good to go. And we've had, around 30 internal recipe developers working and contributing to all of these. So I did not write like these 600 myself. I wrote very few of them, honestly. I wrote a lot of the heavier duty Linux stuff and a lot of the Windows stuff, but my focus was mostly on like tech lead, documentation, training, and helping people and stuff like that, and handling pull requests and all that stuff. So I'm not sure how much I actually wrote, but it may only be like 50 or 60 or something like that. So a lot going on. So what are the challenges? So again, I kind of mentioned the idea of having like a standardized development environment. Like if you know what you're doing well enough and you would rather do this on Mac OS or Linux, more power to you. But we're going to standardize our documentation, we're going to standardize our automation, and we're going to standardize what we present when we do like a presentation to everyone who's interested in contributing to the project internally. Like we're going to do this on Windows using Visual Studio Code. Can you use any other editor besides Visual Studio Code? Sure, you could. And if you really want to, you can. But we actually standardize on using Visual Studio Code for everything we could, even like interacting with Git and using like the source control view in Visual Studio Code to interact with Git. Could you use the Git command line? Sure, that's what I usually use. But I've basically, through this project, trained myself to use Visual Studio Code to interact with Git instead, because that's what a lot of these people that were doing this for the first time or using Git for the first time were more comfortable with, is having some sort of visual tool that they could work with. And so that's kind of what we standardized on. So another big part of this is like setting up the prerequisites for development. Setting up Visual Studio Code, Python, other packages that are required, installing the Python requirements and stuff like that. So we worked on documenting the process, automating the process where we could, And we've made it easier and easier and easier to onboard people to contribute to the project if they want, to the point now where they can basically run one script and they're almost good to go. Another big part of this was like teaching Git best practices. For a lot of people who had done development before, they'd mostly done it where they're the sole contributor to a project, and so they were not used to using branching at all, and they were just like contributing directly, and they were the only ones, actively contributing to a project at a time in, a singular repo, or maybe sometimes there would be 2 people at most. But for us, having 30 people contributing to the project all at once, we had to say, like, you cannot commit to main. We had to protect main branch. You had to make branches. You had to make pull requests, and you had to go through all this process. That's something that a lot of you may never face if you are just doing this inside your own organization and you just have 1 or 2 developers working on this. This is something you probably won't hit, hopefully. But in our case, that became like really necessary. And part of that process is then teaching and training people how to use Git in ways that they have not before, or less likely to do before. And again, I've mentioned this before, regular expressions, GitHub release info provider and URL text searcher. Those are the 2 things we use the most often, and they both use regular expressions. And if you don't know regular expressions, then there's going to be a learning curve. And so teaching people how to use regular expressions and how to get over that learning curve and how to make regular expressions work better and be more dynamic and less likely to break, while also not being too generic that they just grab everything, which is a whole other problem with regular expressions that we had to get over. So part of this that I mentioned is automated setup of the development environment. I have created these scripts: set up Mac, set up Ubuntu, and set up Win for setting up Windows. And in the case of Windows, it will actually install Chocolatey if it's not installed. It will install Python if it's not installed. It will install Visual Studio Code if it's not installed. It'll set up the recipe dependencies of 7-zip, MSI tools, libmagic, stuff like that. Clone the AutoPKG repo. So when we started this project, we were so bleeding edge on AutoPKG that we couldn't actually use the main release branch of AutoPKG at the time. That has since changed, but some of the stuff that was in AutoPKG to make this work was only in the dev branch, so we were actually using the raw dev branch of AutoPKG to make all this work, and it worked out for us. It's definitely not what I would recommend, and you don't need to do that now. You can just use the main branch, or you can use like a release tag of AutoPKG going forward, but we were actually cloning the repo and using the Python code directly to make all this work. I don't know if you want to see that script. Anyone want to see the setup script? Okay. Well, I'm zooming in too much. But yeah, so this is using PowerShell to set execution policy, setting that up in the profile. This is installing Chocolatey here. This refresh environment command, as you're installing Chocolatey and other stuff as you go, the shell that you're running this in won't be aware of like new things that have been added to the path. And so you won't be able to call them correctly until you close the shell and reopen it. And Chocolatey has solved this with this refresh environment command. And so you can just call this and it'll update the shell live. And then you can start calling things as you go and it will work. And so then that's what allows us to call Chocolatey right away and to install VS Code if it's not already installed. Installing Git if it's not there. Installing Visual Studio workload. This is to allow Python to install dependencies that require build. That's what this handles. Installing Python, and then we start upgrading pip, and then other Python modules and stuff like that. Yes. So yeah, and then cloning the repos and putting those in place. So that's the main part of what that does. To do the setup. And so the idea is that you could take a new like macOS VM or Ubuntu VM or Windows VM and set that up as your AutoPKG development environment with like no interaction, setting it up from nothing. And that was the goal. So we could ease the setup process as much as possible. So the other thing that we did is you can add in the repo, if you're standardizing on Visual Studio Code, which I would probably recommend for most things these days, because it's very excellent and very capable, you can actually add a .vs Code folder to the repo itself, and then you can add a bunch of different files to basically help configure VS Code for that repo and repo-specific stuff. So one of them is the extensions.json file, and then inside there we specify what VS Code extensions should be installed for the stuff in this repo to work well for you. And if you open VS Code using the open folder command and open the actual repo that way, it'll say, hey, you're missing some of the extensions that this repo recommends. Would you like to install them? Yes or no? And if you hit yes, then it just installs them. So not only are we automating the setup of the dev environment, but we're also automating VS Code as well. And then same with VS Code settings.json, where you set some default settings in VS Code for the sake of the repo. The launch.json is pretty cool, so we can actually run a recipe directly through VS Code. So if I have a recipe here that I want to run, it seems like one is running already. I can go to run and say like start debugging or run without debugging. And as long as I have a recipe.yaml file selected, it'll actually run it right in VS Code directly. So I just hit run without debugging, and it knows how to call AutoPKG automatically and just runs the recipe. And it's that quick. And that should work on Mac, Windows, and Linux, which is pretty cool. So that way, our recipe developers didn't have to type in the full AutoPKG command line every single time they wanted to run a recipe, just to make it easy, quick and easy. And then for tasks in VS Code, we could set a YAML lint command to run YAML lint against the current recipe to make sure that it's valid YAML. We could run pre-commit to validate the current file or all files in the repo automatically, and there's a bunch of other stuff that we could do. And that way, the recipe developer doesn't have to remember how to run those commands. They can just pull up the tasks menu in VS Code, and it'll list out all the tasks that they can run, and they can just click on it, and it'll just run the task that's applicable. Whoops. So in case of pre-commit, you can actually validate a lot of the different files in here. Elliot over here has a great pre-commit thing called pre-commit macadmin, and it does a bunch of AutoPKG related stuff. And so we can actually test and make sure that our recipes have what we want in them and don't have what we don't want. There's basic pre-commit hooks that are provided by pre-commit itself. There's like check YAML, check that large files aren't added, and a bunch of other stuff. There's this end of file fixer that makes sure there's a new line at the end of every single file and kind of standardizes that. Trailing whitespace one, if you have a line inside of a file and you add whitespace after it and then go to a new line, it will trim that back off for you automatically. And so it does a lot of things to like make sure things are consistent, and including like YAML lints for any YAML files that are in there, which includes all of our recipes and stuff like that. And you can, by default, it will only run against the things that you've changed, but you can actually run it against everything if you want. And it's usually pretty fast. And something failed because apparently I didn't run it against it. So that's, I guess, a good demo. so it found this problem with it, and because now that file's been fixed by it automatically, if I run this again, it should not flag that again because it fixed it. So some of the pre-commit hooks will actually auto-fix the files for you. I did not plan that for a demo. I just screwed up on that one, but it fixed it for me. So that's hilarious. And then I can come in here and I can see what it fixed. And, well, actually, because it's a white space difference, did it show white space difference? Yeah, so I had an extra space here at the end of this command that I did not intend, and it just fixed it for me. So that's awesome. And so we use this quite a bit for the recipes, but we actually use pre-commit and checks for pre-commit very, very heavily with the content that we generate for BigFix. Because the BigFix content that we generate is XML, and so we have a whole bunch of pre-commit scripts that validate that XML and check that it has things in it that we want to be there and doesn't have things in it that we don't want to be there. We don't want AutoPKG variables that were substituted, not substituted, that we thought should be showing up in our resulting content because that means something went wrong, and we check for that with pre-commit. We do a bunch of other stuff with pre-commit that's really cool. And so that's part of the whole process of this is it's not just automating stuff with AutoPKG itself, but it's automating your validation and automating your process and automating all kinds of different checks at all kinds of different levels. And it looks like I'm not going to have time to get into this, but I do have test recipes. The test recipes that I have in my repo, which you can see on my GitHub, allow you, they're basically like examples and ways to test all of the different processors that I've created. So every single processor I created should have a test recipe, and that recipe helps validate the processor itself and make sure the processor is working as designed, but also serves as an example of how you can use that processor as well and what you could do with it. So if you wanted to look at what one of these processor does, you can come in here and run it and kind of see all the different test cases that I've kind of set up in there and how to do it. This is one that I didn't talk about is we also get source release date from the HTTP headers in some cases using that last modified header, and we parse that into a source release date as well. And so here's an example of how we do that. So yeah, check out all those test recipes. There's also a Docker file in the repo. So you can come down here and there's the Docker file. You can right click and hit build image and it'll give you this and you can enter. And if I have Docker running, it'll run and it'll build, and then you can run recipes inside the Docker container, and that's all in Ubuntu. And I have commands down here that you can run to actually invoke AutoPKG through the Docker container, which is awesome. One thing that I'm just realizing that I forgot to mention is if you do not have an AutoPKG config defined, you won't be able to add recipe repos to it for Windows and Ubuntu, or basically anything other than Mac OS. And that is something that I solve in my setup scripts everywhere, and the Docker container. So right here, I'm making a directory for this and making a config file for this. And if you don't make an empty config file, AutoPKG won't make it for you. And then when you go to save things, it won't work. And that's annoying. And then I have GitHub Actions to automate validation and testing of recipes and AutoPKG stuff. Again, that's all in my repo. In the GitHub folder and workflows, I have a whole bunch of GitHub Actions. And you can actually see some of my actions. And apparently some of my last minute changes that I made to some of these things for the presentation caused a failure, so I have to go and investigate that. But what's nice about that is it kind of did it for me, so I can be like, oh, here's a problem in one of the things I changed, I need to go fix it, which is really cool. And it would, yeah, here we go. So here's the actual AutoPKG output, which is very small and hard to read, but it's this one specific recipe that failed. And then and it's because I was missing the MSI info binary, and I need to add that to my GitHub action runner to resolve that. And that would fix the problem. But yeah, here's all the things that worked. So that's cool. But yeah, that's about it. Don't have any time left. Thank you. Yeah.